So today let's start with the topic VLAN, means virtual LAN. Yesterday, before we concluded, we have discussed something about VLAN, right? Like, why do we need VLAN? Can anyone tell me why do we need VLAN? What is the purpose? In short, we have discussed about this concept before we concluded last lecture, right? So what is the purpose of VLAN? Allah says that to solve broadcast domain, Ahmed says split the network. What about others? Someone is saying provide isolation for broadcast. See, solve broadcast domain. It's not a proper answer, or provide isolation for the broadcast is also not a proper answer. But yes, something like that, and not at all split network. That is totally wrong. Now, virtual LAN or a VLAN is the concept where we can divide the devices logically. Now, coming to this packet trace over here, let me take one switch. We all know that if and let me connect one PC as well over here. And let me take one more switch. One more PC over here. I will be connecting this using a cable. Just for our understanding, consider this switch, switch 0, which has 24 fast Ethernet port, and this switch also, which has 24 fast Ethernet port. Now, this PC is there. Assume that you have 24 PCs over here, then you have 24 PCs over here as well. And this is something internet cloud, or let's do one thing just for more clear understanding. Let me do one thing. I will add a router over here which has a internet access. So since this is a router, we need to power on. Just drag this and put it over here, and it should power on now. Yeah, if you can see over here, there is a switch also. So what you have to do, just drag it over here and click on this button, so the router will start to boot. Anyway, router is booted now. Now, sometime the ports will be coming up. We don't have to wait till the port come up. What we have to understand is, now let's say for example you have around 24 PCs connected to this switch, and you have 24 PCs connected to this switch, and specific user sitting over here wants to reach over the internet. So for this user to reach over the internet to this router, you need to go to the switch and directly to the router over here, instead of passing the traffic to the complete network. I mean, sending the broadcast traffic to the complete network. So what we can do is we can divide the devices logically. This switch, if you will see this switch over here, if you see the switch, just one second. Okay, so if you see this switch, what you can do, let's say for example this R6 port, you can virtually divide the switch. You can logically divide this device, this switch port. You can logically divide, and you can put it in one VLAN. You can then, moving ahead, you can say that okay, then this ports will be in some separate VLAN, you can say that the remaining ports will be in separate VLAN. Now, what will happen? The device receive the request on one of its port, amongst the first six port, any of the port. What will happen? The broadcast request, if required, will not go to another ports. It will not go to another VLAN. So, dividing the broadcast domain, the concept by which you divide the broadcast domain in switches is called as VLAN. Is it clear? Now, moving ahead with the discussion, close this. This router is not coming up, right? So the router has booted up, but you can see that the ports are not coming up. The ports are still down. So always remember that by default the router ports are shut down. If you want to verify, you can just say no. For you don't have to go for the initial configuration. Now see, it is asking, would you like to enter the initial configuration dialog? You will say no. If you say yes, it will ask you for the primary, basic configuration, like if you want to put the host name, you want to configure any IP address, and so on. If you want, you can try it at home, saying that yes, and it will ask you many questions. It will give you many suggestions, and you can configure it by default one by one. The default setting can be configured if you say yes, I want to enter the initial configuration. But now I'm saying no, and I will hit enter. Now if you see over here, give the command show IP interface brief, hit enter. Now see, the ports are down. So by default, when the router boots up for the first time with the initial configuration, you will see that the ports are down. And now if you make the ports up, let's say for example, you go to configure terminal over here, you go to the interface configuration mode for interface GI0/0 and give the command no shut. Similarly, go for interface GI0/1 and give the command no shut. I think these are only the two ports which are connected to the switches. Yes, now see, the port has come up, and you will see that in some time on the switch side also the ports will come up. Anyway, this is not the part of the discussion, but the main concept was how you can divide the broadcast domain. Now, let's say, for example, you have put this switch ports amongst the 24 switch ports. You have put 8 ports in one broadcast domain, 8 ports in another broadcast domain. So, the broadcast traffic from one broadcast domain will never pass to another broadcast domain. Is it clear? Any questions? Any doubt over here? So, broadcast domain is a network segment which we have understood that if a device broadcasts packet, then all the devices, if this switch broadcast a packet, then all the switches will receive in the same broadcast domain. All the switches will receive the broadcast request. Why? Because switch is a single broadcast domain. This is what we have discussed when we were discussing about collision domain and broadcast domain. The switch is per port collision, and it is single broadcast domain. Now we have understood the pain if all the switches in the network are in single broadcast domain. So just assume that how much broadcast traffic will be going out and coming in, and there is a possibility of congestion due to this unnecessary traffic. So what we can do, we can divide the broadcast in switches, and this is nothing but a concept called as VLAN, virtual LAN. Now, once you have divided the switches into different broadcast domains, so by default, one broadcast domain will not send a broadcast to another broadcast domain. Is it clear? Any questions? Any doubts over here till here? Now, we will try to understand how you will create a broadcast domain, how you will be dividing the switches using different broadcasts, that we will understand. This is very, what you will do over here is, now this is a switch for example, and if I say that I want to divide the, give the command show IP interface brief, and my requirement is the first 8 ports of the switches will be grouped in one broadcast domain, and the remaining 8 port will be in some other domain, and the remaining will be in some other domain. So what I have to do is I have to create the VLAN. I have to create VLANs, and how we will create VLAN, that we will see. But before that, just understand that now it's very simple how to create a VLAN. What you will do, you will go to the port. Let's say, for example, you will go to port number 1, configure terminal interface FA0 by 1, and you will be assigning the port VLAN to this, and it will become a member of this VLAN. But before that, remember, in switches, in switches, by default, all the ports of the switches are the member of VLAN 1. Remember that by default, all the switch ports are the member of VLAN 1, means all the switch ports are a member of single broadcast domain, and that broadcast domain, that broadcast ID or a VLAN ID is VLAN 1. So there is one VLAN, that is VLAN 1, running in the switch by default, and all the ports are the member of VLAN 1. Now, if you want to check VLAN in the switches, the command is show VLAN, and you will see that there is VLAN 1. We have not created any VLAN till now. We have not created any VLAN, but you can see VLAN 1 is there by default. Name is default VLAN, and you will see that all the ports of the switch, from fast Ethernet 0 by 1 to fast Ethernet 0 by 24, and gig 01 and gigabit Ethernet port 0 by 2, all the ports are the member of VLAN 1, meaning that all the ports are the member of single broadcast domain. Then you will find something 1002, 1003, 1004, 1005. This will understand what it is. But always remember, by default, all these ports of the switches, all the switch ports are the member of VLAN 1. What is this one? It's nothing but an ID, VLAN ID. Now we need to understand how this ID works. Now VLAN 1 is there, so how many numbers you can define, what is the range, and what you can use, what you cannot use, this all thing we will understand. Now VLAN ranges are there. There are range of VLAN which you need to know. So there is something called VLAN 0 and VLAN 4095. These VLANs are reserved VLAN. These VLANs are reserved VLAN, and it cannot be seen or it cannot be used also. These are the reserved VLAN for some purpose, and it cannot be seen on the switches, nor it can be used. Then we have VLAN 1. Just now we have discussed. It is a default VLAN. It is a default VLAN of switch, and we have just discussed that by default all switch ports are in VLAN 1. We have seen also. And always remember this, that default VLAN, that is VLAN 1 over here, it can't be deleted. It can't be deleted or edited. But this can be used. Like VLAN 0, I have said, now it cannot be used, but this is not the case with VLAN 1. VLAN 1 is a default VLAN. It can't be deleted or edited, but it can be used. Then we have from VLAN 2 to range 1001. From VLAN 2 to 1001, this is a normal range. of VLAN. This is the normal range of VLAN. So, being an administrator, network administrator, we can create, edit, and if required, we can delete this VLAN. So, in your normal day-to-day operations, where you want to b- break this broadcast domain, unnecessary broadcast, if not required, you can do it by creating a VLAN. And the VLAN, when you're creating, it's created on the basis of ID, VLAN ID. So you can use this VLAN ID from ID number 2 to ID number 1001. These are the normal range and you can use it. Then we have something VLAN 1002 up to 1005. So these are again Cisco default VLAN. These are again Cisco default VLAN for FDDI and token rings, which were used in olden time. In earlier time, it was used, and again, this VLANs can't be deleted. And finally, the last VLAN which we have is VLAN 10624094. This is called as extended range of VLAN. Now, what is extended range of VLAN? We will understand in next week when we will be having a lecture on SVIs and all. There is concept called SVI and all. At that time, we will be understanding what is extended range of VLAN and why it is required, how it works. But just for now, remember that if you want to break a broadcast domain, you have to create a VLAN, and VLANs are creating using VLAN IDs. You have to define IDs to create a VLAN because switch identifies a VLAN ID. Now, VLAN 0 and 4, the VLAN range is from 0 to 4095. VLAN range is from 0 to 4095, where VLAN 0 and 4095 are the reserved VLAN and it cannot be seen on your switches, nor it can be used. VLAN 1 is a default VLAN, so it cannot be deleted or edited, but it can be used if required. Then VLAN 2, VLAN 1001, this is a normal range. Being a network administrator for designing your network, you can use this VLAN range. We can create it, you can edit it if you want to do any kind of changes, and we can delete this VLAN if not required. Then VLAN 1002 to 1005 is Cisco default VLAN, which was used in earlier days, but now that is not no more in use. But yes, Cisco still has that, and you can see it over here. 1002 for FDDI default, token ring default. These all are the again default VLAN which cannot be deleted. And finally, this is something which we are going to discuss in our next week lecture. Any questions, any doubt till here to anyone? So now switch ports, the port of the switch ports are layer 2 interfaces, right? That are used to carry layer 2 traffic. Now we have discussed that switch is a layer 2 device. Later on, this will change, and there are many things going to add on the top of this. But for now, just understand that switch is a layer 2 device. So the port of the switch are nothing but layer 2 interfaces. And since they are the layer 2 interfaces, they will be carrying layer 2 traffic. Now, always remember that to break the broadcast domain, what you will do, you will be assigning, you will be assigning the VLAN. Means you will be assigning the VLAN ID to switch port. You will say that, okay, port number 1, you are the member of VLAN 10, for example. So you are assigning the VLAN ID to switch port. Now, once you assign, what is going to happen is a single switch port can carry single VLAN traffic. Meaning, over here, come over here. This is your switch. Now, let's say you have 24 ports over here. You said that fast Ethernet 0 by 1. You said this, you are the member of VLAN 10. What will happen? This will only carry the traffic of VLAN 10. If there is any traffic coming from VLAN 10, if there is other port, let's say fast Ethernet 0 by 18 is also member of VLAN 10. This is also coming in the broadcast domain of VLAN 10. Then we fast Ethernet 0 by 1 and 0 by 18. They both will talk to each other. But now over here, fast Ethernet 0 by 2, you said that you are the member of VLAN 20. Then in that case, you know what will happen? Fa- Fast Ethernet 0 by 1 will not carry the traffic of 0 by 2. If there is any traffic coming from 0 by 2, which is a member of VLAN 20, Fast Ethernet 0 by 1 doesn't know, because both are in different broadcast domain. Is it clear? Now, there are two different type of ports in switch environment. In the switch environment, when you talk about the switch environment, there are two different type of ports. In switch environment, there are two different types of ports. There are two different type of ports. What are they? Access ports. Another one is trunk ports. We will understand what are access ports and what are trunk ports. Now, we will understand what are access ports, what are trunk ports. So when you talk about access ports, what you do is you go to a specific switch port. Now, going to configure terminal mode, you go to interface FA 0 by 1, and you say that you are a member of broadcast domain VLAN 10. You are a member of VLAN 10. So when you say this, that you are a member of VLAN 10, what is going to happen? What is going to happen? This switch port 0 by 1 will only carry traffic of this broadcast domain, which is VLAN 10. It will carry the traffic of only VLAN 10. And can anyone tell me, if I don't give this command, if I don't say to the switch that you are a member of VLAN 10, so if there is no VLAN membership assigned to the port, in this case, which traffic it will carry? Which traffic it will carry? Which VLAN traffic it will carry? Correct. By default, it will carry the traffic of VLAN 1. Yes, Ahmad, be patient. Your question will be answered very soon. If everything I will explain over here itself, then this lecture will become the last lecture. So be patient. Your query will be answered. So if there is no membership assigned, then by default it will carry the traffic of VLAN 1, because by default all the switch ports are the member of VLAN 1. Now let's say we have understood that what is access port. It is something like where that switch will if the port is an access port, then in that case switch will be carrying the traffic of only that VLAN which is assigned to that port. And by default, now let's say we know that by default all the switch is a member of port 1. Now if you go over here on the interface and you say that switch port mode access, you are saying that the switch port is access type, the port of the switch is of the type access. You give this command and you don't assign any membership, only you say that this switch port is access port. Then in that case what is going to happen is, and if you give the command to all the interfaces, that is interface range, I can say from fa 0 by 2 to 48, you give this all the interfaces, only this command, switch port mode access. So if you give this command, then what will happen, you are not assigning any VLAN. So all the switch ports, all these 48 switch ports will be a member of single broadcast domain, will belong to single broadcast domain. Why? Because there is no membership assigned. Only you said that the switch port, your mode is access mode, and if the switch port mode is access, in that case the switch will carry a traffic of only one VLAN. Which VLAN? To which it is the member of. And if you are not assigning any membership, so by default it is a member of VLAN 1. Is it clear? Now now coming to the packet tracer over here, just delete this router. delete, delete this router, and what you have to do is simply connect this switch to this switch, and just take one more PC over here and one more PC over here, and connect this to the switch. Okay, everyone is ready with the setup. Everyone is ready with the setup. That's good. Now just give the IP addresses to this PCs, and the IP address can be 192.168.1.1/24, means 255.255.255.0. 192.168.1.2. Then 192.168.1.3, and finally to the PC4 it will be 192.168.1.4. Everyone has given this IP address. Everyone has given. Okay. Now see, we have not done any configuration, meaning that all these switch ports are the member of VLAN 1 by default. What you do is just check on which ports you have connected these two pieces, FA0 by 1 and another port is FA0 by 3, 1 and 3, right? 3 and 2. So basically 1, 2, 3 are coming into the role, right? So, so what you will do over here is simply you will go over here, go to CLI. Now, before that, just come over here and go over here in 192.168.1.4. See, the reply is coming. Let's see it on simulator how the traffic goes. Okay, let's see it on simulator as well. Simulations, just go to simulations. Okay, go into simulations, take the packet and put it. Oh, sorry, this is not going to come here. Delete the scenario, reset simulation. Just take the packet, go to PC0, and this is PC1, right? Come over here, open the simulation. Okay, so you can see PC0 traffic has started. It has broadcasted to all the ports. Before, but what happened, you can see over here, instead of asking for the ARP request, you will see that the reply from PC0 went to PC1. Why? Because just now we have ping, na? So it has a MAC address, but this will not be the case in another PC. What we will do, just for the testing purpose, let's do one thing. Let's do one thing. First of all, we will just take it over here so that we can have a visibility. Okay. Now what we will do over here is we'll try to ping PC2 to PC3. Okay. Why there was no ARP request and all shown? Because by default, just sometime before we had ping PC0 to PC1 using command prompt, and everything was the MAC address was stored in the cache, right? Now over here, try to ping PC2 and PC3. You see there is a packet over here going to switch 0. Now see, the same packet is broadcasted. It comes over here also and it goes over here also. This is nothing but a ARP request, right? Initially, because PC2 doesn't know the MAC address of PC3. So when this reaches over switch, and PC2 has created a frame asking for the MAC address of PC3. In the frame, there is a source IP, destination IP, and the destination source IP, destination IP, source MAC is there, destination MAC is unknown. So now when it reaches the switch, it has broadcasted requesting for the MAC address. It goes to PC0. As you can see, PC0 has discarded because the destination IP doesn't belong to him. At the same time, the switch has forwarded this to this switch also. And now see what happens. Switch again forward the ARP request to both the PCs also. PC1 has also declined. Why? Because the destination IP was not there and it has reached to PC3 also. Now you can see that PC3 has accepted and sent the request again back, a response. This is nothing but a response packet now going, which will be unicast and it will go to PC2. Let's see. Now it has reached over here. Now the another packet which will go will be the ICMP. The actual ping packet will go now here from here. This is nothing but a ICMP packet. Now ICMP packet will go and it will be successful. Basically, you will see that this PC2 wants to talk to PC3. It was not having the MAC address entry in its PC, so it has gone to switch. Then it has broadcasted. So basically, just for this one switch to communicate, this was a broadcast. Understand that if there are thousands of pieces, how much broadcast will be there? Unnecessary broadcast will be there. So this broadcast domain we can divide it. Now, if in case this is a member of a specific VLAN, then this broadcast will not go to another all VLANs. It will go to specific that VLAN only, and in this case you can break the broadcast. Moving ahead, now we have seen that you have connected the pieces and by default all the pieces are talking to each other. Now moving ahead, let's do one thing. We will learn how to configure the access port. So just go to configuration mode along with me, and we need to configure fast ethernet 1 2 3, right? So see, if you want to do the same configuration on multiple port numbers, what you can do is you can use the interface range command. Instead of going and configuring interface one by one, you can give the command int for interface range, and the port number fa0 by 1 to 3, and hit enter. And at the same time you can configure all these three ports: switch port, mode, access. Hit enter. Control Z and come out. Now give the command show run to check the running configuration, and you have configured switch port mode access. You can see for 1 2 and port number 3, switch port mode you have changed to access port. Everyone has done this. Now just close it, and over here you can come to this switch, come to CLI, and go to privilege mode, go to configure mode, and do similar thing over here also. Interface range FA0 by 1 3, switch port mode access. Now close this also. Even now if you try to ping PC1 to PC0, try to ping PC1 to PC0, come to command prompt. PC0 IP is 1.1, 192.168.1.1. So now this is PC1. I will try to reach out to PC0 over here. Just I will click over here and going to command prompt. I will see that ping 192.168.1.1, or let's do one thing. Instead of 1.1, we'll try to ping this new PC 1.2. Hit enter. So it is pinging. So what we did, see, we know that this PCs are the member of VLAN 1 by default. These PCs are the member of VLAN by default. So these two switches which we have connected, we made it an access port. Why? Because all the traffic which will be passing from here is going to pass through a single VLAN. So there is no issue. That's the reason we made it access port, because we know that access port carries a traffic of single VLAN. And since over here also we were having VLAN 1, over here also we were having VLAN 1, we configured this as an access port and the traffic was moving on. So you don't need to configure these ports which are connected to pieces. But if even you configure only this port and this port, the port between the switches as an access port, that should be fair enough and the communication is established. Meaning that this is justified that if the port is access port, it carries a traffic of single VLAN. Now, now there is something, another type of port called as trunk port. Another port which is called as trunk port. Now, as like access port which carry a traffic of single VLAN, trunk port carries the traffic of more than one VLAN. Trunk port carries the traffic of more than one VLAN. Trunk port carries traffic of more than one VLAN. Now, this is the advantage. For example, in our scenario which we have considered over here, let's say these PCs are in different VLAN and these PCs are in different VLAN. If you configure these two ports as the access port, do you think that the traffic of these PCs will be going to this PCs, or do you think that, let's say, for example, these PCs are there and then you have these PCs. Now, let's say, for example, these PCs are in VLAN 10 and these PCs are in VLAN 20. If you configure this, this port over here as access port, and similarly if you configure this also as access port, do you think that these pieces which are in VLAN 10 will be able to talk to VLAN 20? The answer is no. Why? Because we know that access port carries the traffic of single VLAN. Now this VLAN traffic goes to this port. For example, this PC0 traffic goes to this port over here, and what will happen? Then it will be forwarded, it will be broadcasted, it will come over here, it will go over here also. Now once the traffic comes over here, it will be forwarded over here. This is the access port. It will again broadcast and the traffic will go over here. Now this port is a member of VLAN 20 broadcast domain which doesn't know what is VLAN 10, and it will be discarded. Now exactly what happened over here is, let me tell you one thing. This access port, this is the access port, okay, and by default, just forget, it will not even go till here. Just forget, it will not even go till here. For example, if this is the access port configure and there is no VLAN, if it is having VLAN 10, it will forward it over here, okay. But if in case there is no VLAN over here, the VLAN 1 is there, the default VLAN is there. If the traffic goes from here for VLAN 10 and this access port doesn't even know what is VLAN 10, it is a member of VLAN 1 because access port carries the traffic of single VLAN. The traffic will be discarded over here itself. But again, consider that even you have considered this port as VLAN 10, then the traffic will go till here. If this port is also VLAN 10, the traffic will be forwarded and over here somewhere it will be discarded because these ports are member of VLAN 20. But even if this port is not a member of VLAN 10, the traffic will be discarded here itself because by default the access port doesn't understand that doesn't accept the traffic of another VLAN. It accepts the traffic of its own VLAN using a VLAN ID. Is it clear? So that's the reason where the trunk ports come into the role. So if you want to make it possible that a port must carry a traffic of multiple VLAN from one side to other side, then you need to configure the trunk port. What you need to configure? You need to configure the trunk port. And how you will configure the trunk port, that we will see. But before we move ahead and do the practicals, let's take a break of 5 minutes and then we will continue. So now we are going to do the small lab on trunk ports. Earlier we have seen that we have connected the switch in the similar topology we made this the ports between the switches to be access port, and we have seen that the switches were able to communicate to each other. Why? Because all were in the same VLAN, and access port carry the traffic of only single VLAN. But yes, there is some question from Imran. Now, during the time of break, now since Imran question is clear, anyone has any questions? Anyone else has any questions? Nothing? Okay. In the break time, I have made up this design and we are going to do a practicals on this. Now, what I have done, I have taken two switches and I think for you also the lab is ready, right? Everyone lab is ready. Please confirm in the chat box. So we have taken two switches. For this switch, port number 1 and port number 2, I have connected two pieces. Over here also on port number 1 and port number 2, I have connected two pieces. Okay. And in between, I have assumed that I will be configuring the trunk port between these two switches, which is port number 3 on this switch and port number 3 on this switch. What I have done over here is, since we have to do a trunk, we have to see how the trunk port works. What I have done is to justify that trunk port carries the traffic of multiple VLANs from one side to another side. I have kept one PC in VLAN 10, another PC in VLAN 20. Means I have kept one PC in a broadcast domain of VLAN 10, another in VLAN 20. Over here also VLAN 10, VLAN 20. Is the design clear to everyone? And the IP address scheme is there. Now, our requirement is all the PCs in the network should communicate to each other. How we will do the configuration? Let's start doing the configuration. What are the steps? Now I have said you that assign the VLAN and all. So remember, when you assign the VLAN to a port, automatically that specific VLAN is created. For example, if you say that VLAN 10, then this VLAN 10 will always be created automatically in the backend. That also we will see, but it is always a good practice that you create a VLAN in the switch first. So what is the first step? Just we will go to this switch. Before that, we need to configure the IP address as per our design in all the PCs. Go to desktop, and over here in IP configuration, I will say 192.168.10.10. I will close it. I will go over here. It is 20.10. It is 20.10. 192.168.20.10/24. Close it. This is going to be 10.20. And this is going to be 20.20. Now we'll start configuring the switch. You go over here, configuration, come to CLI, and over here go to privilege mode. The command is enable. Now the very first thing what we have to do is we have to create VLAN 10. How to create VLAN 10? Go to configuration mode and say VLAN 10. VLAN 10. Even if you type VN, it will work. Okay. Enter. You know what has happened in the backend? You will check the VLAN. The VLAN 10 is created. Everyone knows that in our previous lecture I had told you, if you want to run the privilege command in some other mode, what is going to be the command? Do show VLAN, right? But over here in packet tracer that doesn't work. So show VLAN, and you will see that, see, for everyone VLAN 10 is created. Now One more thing, if there are hundred of VLANs in your network and it is difficult to remember by the number, what you can do, you can give the name also for that VLAN. So go to configuration, go to VLAN 10 and give the name for name, let's say name IT. Okay, enter. Now come out from here, exit, and we will create one more VLAN over here, that is VLAN 20. So say VLAN 20, name, give HR department. If this network belongs to HR department, give the name HR, hit enter. Press Ctrl Z and come out. If you check show VLAN command, it will give you the VLAN details. See, VLAN 10 is created and the name is IT. VLAN 20 is created, the name is HR. Everyone has created this. Now, once the VLANs are created, this then we need to assign this VLANs to this port. This port should become the member of this VLAN, right? Now we will learn how to assign the VLANs to the port. So as per our design, this port number fast Ethernet 0 by 1 belongs to VLAN 10. So how we will assign? Go to configuration mode, configure terminal mode, go to interface FA0/1, hit enter and give the command switch port access VLAN 10. And always remember that these ports will be the access ports, the ports which are connecting to a single VLAN. Now over here, this PC is connected now. So this PC is a member of VLAN 10. The IP scheme of the VLAN 10 we have set 192.168.10.10. So simply say that switch port mode access, or even if you don't say, that's okay. For now, don't give any switch port mode access command. For now, don't give any switch port mode access command. Okay, we will see this later. Once you have made this as a member of VLAN 10, just exit from here. And another port, interface FA0/2, make it a member of VLAN 20. Hit enter. Everyone has done this. Finally, we need to make this FA0 by 3 as a trunk port, right? So let's go ahead. Let's go ahead and say FA0/3 switch port. Remember, the command is switch port access. Let me write down the command. If you want to assign the membership, if you want to assign, I will write it later because I am using a shortcuts. So don't get confused. But I will use the complete command now better. Switch port mode trunk and hit enter. Okay, and just need to check if the encapsulation is required. Switch port trunk encapsulation not required. It's the latest way. Okay, fine, that's good. We made it as switch port mode trunk. What was the command? Switch port mode trunk. Switch port mode trunk. You made port number 3 as trunk. Okay, you have made the port as trunk. Now close it. Come over here on PC3. Sorry, come over here on the switch. Similar configuration we have to do over here also. Port number 1 VLAN 10 port number to VLAN 20, right? So we will be creating VLANs over here also. Configure T, and I will say VLAN 10. Name is IT. Exit. VLAN 20. Name is HR. Imran is saying that not showing VLAN created. Where it is not showing, Imran? So that's good. Imran has sorted out his own issue. That's good, Imran. We have created this two VLAN. Just to verify, you will say show VLAN and you will see that VLAN 10 and VLAN 20 is created over here. VLAN 10 with the name IT and VLAN 20 with the name HR is created for you. Now it's a time to assign the membership. So you will go to configure terminal. You will say interface FA0/1 switch port access VLAN 10. Exit from here. Go to interface FA0/2 and say switch port access VLAN 20 and Control Z. Everyone has done this configuration. Everyone has done this configuration. Please confirm in the chat box. That's good. Now, just come to PC1, come to command prompt and try to ping the IP address of PC4, which is 192.168.20.20. Are you able to ping? Are you able to ping? No. Anyone can tell me why we're not able to ping? Can anyone tell me why we are not able to ping? We are missing something. Is there any smart personality in the class? Why we are not able to ping? We have configured the access ports. We have assigned the VLAN. We have configured the trunk port. We should be able to ping, right? Why we are not able to ping? No, Ahmed, you are wrong. Yes, Allah is right. So this is not a complete configuration actually, but just to show you how the trunk port works. Now, for making this to work, what you need is you need inter-VLAN routing. What you need is inter-VLAN routing, and how that happen? That now we will go ahead and do it. Till now, what we have understood is how to how to make this how to make this switch configure as the VLAN, how to configure the VLAN on the switches, how to make the port as trunk. This we have discussed. But apart from that, there are many things. Inter-VLAN routing is one powerful concept that we have to learn. Till now, what you have learned is how to make the port as access, how to create a VLAN. Then what else we have learned? How to assign the VLAN to a port, how to make a trunk port. Now, going ahead with the discussion, we need to have this PC1 to communicate to PC3, PC4. All the ports should communicate to each other. And for that, what we need is we need inter-VLAN routing. We need inter-VLAN routing. Now, let's go ahead and learn inter-VLAN routing. Just give me 2 minutes, please. Okay. So, to perform inter-VLAN routing, we will need, as the name implies, routing, we will be requiring a layer 3 device. What we'll require is layer 3 device. Now, we will learn how to do an inter-VLAN routing, but before that, we will be understanding some important concepts of switching. We will try to understand layer 2 switching, layer 3 switching, and then we will move ahead. But everyone got an idea? Everyone got an idea like how to configure the access ports, how to configure the trunk port. Let me just summarize this before we move ahead with the discussion. Let me summarize this over here on the board. So, what are the steps? How to create VLAN? It is simple. VLAN, the command is VLAN and ID. You have to give the VLAN ID. VLAN followed by VLAN ID. It will create a VLAN. You can give the name of the VLAN, whatever you want. In our case, we have given IT HR. This you have to do in configuration mode. This is how the VLAN is created. Then, if you want to assign this VLAN, what you have to do, you have to go to configuration mode. You have to go to the interface, and then you have to say that switch port access VLAN, for example, 10. Switch port access VLAN 10. Let me write it fully for you. Switch port access VLAN. If you want, now this port should be accessed, so you have to give the command switch port mode access. Now, if you want to create a trunk port, let's say, for example, you will go to configuration mode, you will say interface name, and you will say that switch port mode trunk. We have learned this. We have learned how to create a VLAN, how to assign a VLAN to the port, how to make a port as a trunk. This we have learned till now. Now, moving ahead, we have seen that we were not able to communicate this PC to another PC, and that is quite normal. That is quite normal because if there are two different networks, then in that case, the layer 2 device is definitely not going to work. We need the concept called inter-VLAN routing. What is inter-VLAN routing? Inter-VLAN routing means, as the name implies, routing between two different VLANs. We have VLAN 10 over here and VLAN 20 over here. And now if you want to communicate VLAN 1, VLAN 10 and VLAN 20, what you need to perform is inter-VLAN routing. What you need to perform is inter-VLAN routing. Let me write down over here. You need to perform, if you want two VLANs to communicate to each other in your network, you need to perform inter-VLAN routing, meaning routing between two different VLANs. And for this, you need layer 3 device. Now, we will discuss some important concept, different type of switches available in the market, and then after understanding their functionality, we will proceed with the inter-VLAN routing. We will be doing some changes in this lab, and over here only we will be doing the inter-VLAN routing. So now what you have to do is you have to just listen to me. You can just close down your packet tracer. It's not required for now. Now, how the traffic is forwarded in switches, how the traffic is forwarded. Now, if a PC1 which is connected to the switch wants to talk to a PC2 which is connected to another switch, how the traffic will be forwarded? Forwarding of the traffic, forwarding of the frames based on layer 2 address is known as switching. What is switching? If someone asks you, forwarding of the frames are forwarded, right? We have seen that even if the ARP request, if the ARP MAC address need to be learned, then the ARP protocol comes into the role. And what switch does? Switch creates a frame, right? Which contains source IP, destination IP, source MAC, and destination MAC is unknown. It is a frame. So forwarding of the frames on the basis of layer 2 address. Layer 2 address means MAC address or the physical address is known as switching. Similarly, forwarding of the packets on the base of layer 3 address is known as routing. If the packets are forwarded on the base of IP addressing, it is known as routing. If the frames are forwarded on the base of MAC address, is known as switching. Is it clear? Now, one more important thing, just note down whatever I'm saying, start noting it down. Devices that forward the frames on the basis of layer 2 address are known as layer 2 device, or even I can say that such as layer 2 switch. There are different type of switches now. Layer 2 the switches are defined as layer 2 switch, layer 3 switch. We will understand one by one. So very first thing you have to understand is forwarding of the frames. When the frames are forwarded on the basis of MAC address, it is nothing but called as switching. Similar to the router, when the forwarding of the packets are done on the basis of IP address is known as routing. Forwarding of the frames on the basis of MAC address is known as switching. So I can say that devices that forward the frames on the basis of MAC address are known as layer 2 devices, such as your layer 2 switch. The one which you are seeing over here in your lab, it is a layer 2 switch. What is layer 2? What is layer 3? How to, everything we'll discuss. Don't worry. Now the switches are of different type. One is layer 2 switch. Layer 2 switch. What it does? Forwards frame based on layer 2 address only. It doesn't understand IP addressing and all. Forward the frame based on layer 2 address only. And there is something called layer 3 switch. Something called layer 3 switch. Now over here you cannot do any layer 3 functionality. IP addressing and all you cannot configure on the switch port. You cannot go to switch port and configure the IP address because it's a layer 2 switch. It doesn't understand what is IP addressing. So on the interface you cannot go and configure the IP address. One second, let me show you. The command itself will not work. Let's do one thing. Go to enable, go to configuration mode, go to interface FA0 by 10 for example, and give the command IP. See, IP address itself is not, the command itself will not work because it doesn't understand the IP addresses. It's a layer 2. It works on MAC addresses, layer 2 addresses. That's why it is called layer 2 switch. Then comes a layer 3 switch. Layer 3 switch. What is layer 3 switch? Layer 3 switch can do forwarding based on layer 2 address as well as layer 3 address. So I can say that in the layer 3 switch, routing capabilities are there. This layer 3 switch is capable of doing routing. So in our scenario, in our lab over here, if I want to communicate these two PCs which are in different VLAN, then I need to put the layer 3 switch in between, which is capable of doing routing. And inter-VLAN routing can be done. But remember, the question might come to your mind that if the layer 3 switch is capable of doing the routing, why do we need router? Remember, layer 3 switch is capable of doing routing and all, but all the functions are not covered. Like for example, if you say that if you want to do a natting, that is something on layer 4, the natting function doesn't work on layer 3 switch. You cannot do natting. For that you need router only. But yes, inter-VLAN routing or some other routing protocols can work on layer 3 switch, but not everything. That has a limitation. So layer 3 switch can do forwarding based on layer 3 address. Layer 2 address means it can work on MAC address as well as it will work on layer 3 address, that is nothing but a IP address. It do understand the IP address as well. Another type of switch is multi-layer switch. Multi-layer switch. It can do port forwarding also. Meaning it can do port forwarding also, means it is capable of performing the netting and all. Or the better word is not, you can say packet forwarding, can do port forwarding, whatever. So this is something capable of doing all the tasks. Multi-layer switch is capable of doing all the tasks. Now in the lab over here you can see 2960, right? So earlier what used to happen in olden times, the switch models were something different, and now in modern days it's totally a different models which you can see in the market. So since almost of them over here are working, so can someone tell me what are the model or what are the switches which you have seen or have worked on? Can you put in the chat box? The switches which were coming before were Cisco 2960, Cisco, then 3750 series, then 4500 series. These all switches were coming before. Now, now to understand what it is a layer 2 switch or a layer 3 switch. In olden time, it was very easy. It was very easy. Since the series starts with 2960, two number, it was the layer 2 switch. In olden time, Cisco 2960, if someone says, it is layer 2 switch because it was easy to identify. Then if someone says Cisco 3750 starting with 3, so it is layer 3 switch. Then we were having multi-layer switch, that is Cisco 4500. This was, I can say, campus area network switch, right? This was the modular switch, you can say, because it was having modules. Everyone has seen the switches. Or you can do one thing, you can just go to Google and look for the switches. So it was Cisco 4500 series, and the switch was 4507 because it was having 7 modules, and that 7 different modules were there. So it was Cisco 4507. But now Cisco has put all the switches to end of life, and they have come up with a modular, with the new modern day switches. And today's switches, most of the switches that comes today are routing capable. It is software based licenses. They have introduced software based licenses. You need to apply the licenses, and the switch is capable of doing the layer 3 job as well. In olden time it was not the case. If it is 2960 means mandatory, it is a layer 2 switch, you cannot perform layer 3 switching. But now the licenses are software based, so everything has become possible nowadays. But what happened, Cisco has put this switch as end of life. Okay, it is announced end of life long time back, and now the equivalent model is 9200, Cisco 9200. Okay, even this layer 3 switch 3750 is end of life, and new model is 9200. To avoid confusion, we can say that replaced replacement is 9200. Okay, now Cisco 3750 is end of life, and the replacement is 9300. Similarly, Cisco 4507, a campus area network switch, is announced end of life, and the replacement is, let me write down over here itself, replacement is 9400. Now, understand how this has the replacement, how you will learn this. Remember that this starting two number, it is said, there is no official document, but it is said 2960, which was categorized as layer 2 from the starting number, they have put over here. Now all the switches has come with the 9000 series, and this 2 is nothing but represented as a layer 2. This 9300 represented as a layer 3, and 4507 is replaced by 9407, and that is the equivalent switch. Is it clear? Any questions, any doubt over here? Any questions, any doubt over here? Anyone has any questions, any doubt? If everything is clear, then move ahead. So most of the switches today are routing capable. So some of the few catalyst switches typically used in a modern campus network we have discussed: 9200, 9300, 9400 series switches are coming nowadays. Now we need to understand what are the type of ports on the catalyst switch. Types of ports on a catalyst switch. For this discussion, we need to have some basic understanding of VLAN. Actually, I was not supposed to take VLAN first, but we need to understand, have some basic knowledge. We are going to do super advanced labs also, but basic thing was required to understand these things. Basic things in the sense, what is VLAN, then apart from that, what is access port, what is trunk port, this was required. Now we will understand types of port on a catalyst switch. So guys, always remember that when you talk about a layer 3 switch, and nowadays modern day switches are all layer 3 switches only, a switch port on a layer 3 catalyst switch can be configured to operate as either a layer 2 port or a layer 3 port. What you can do, if you have a switch, you can decide whether you want this switch to be working as a layer, the port of the switch to be working as layer 2 or layer 3. We will see now how to do that. Now we will see how to do that. Okay, so switch port on a layer 3 catalyst switch can be configured to operate as layer 2 port or a layer 3 port. Being administrator, you can decide the switch port of the specific switch. You want it to work as a layer 2 or layer 3. Meaning that if you say that the port is a layer 2 port, so if it is a layer 2 port, work based on VLAN membership assigned on it. It works on VLAN membership. You have to assign, if it's a layer 2 port, you need to assign a VLAN membership. We have seen how to assign a VLAN membership. And if it is a layer 3 ports, so if it is a layer 3, as the name implies, layer 3 address will be required. So it must be configured with some IP address to be fully operational. So the switch port of the layer 3 switch, layer 3 catalyst switch can be configured as either layer 2 or layer 3. If it is layer 2, then in that case a VLAN membership need to be assigned, and if it is VLAN 3, so if it is a layer 3, then IP address need to be required over here. How you will configure the port as a layer 2 or layer 3? So for doing that, what you need is just do one thing. We are talking about a layer 3 switch. So for now, I will be just deleting this lab. We don't need everything over here for now. Let's take one layer 3 switch over here. Let's take one layer 3 switch over here. Come over here, come to switches, and over here you will find one switch 3650. Take the switch. Okay, take the switch. Just double click over here on the switch. See, by default this switch is power off. Okay, this switch is power off. See, the device must be power on, right? So just take this power supply over from here and put it over here. Okay, and go to CLI. The switch is booting now. It's a layer 3 switch. So in the simulator, this layer 3 switch need to be power on. It is again asking you that would you like to enter the initial configuration. At home, just say yes and see. It will ask you to do a basic configuration. It will ask you to do the basic configuration. But now here simply say no and just skip from the initial configuration. Press enter to get started. Okay, give the enable command to enter into the privilege mode. Now you are into the privilege mode. Very first, we need to learn how to check the port is a layer 2 port or a layer 3 port. That is the first question. So just check what are the interface details. Show IP interface brief. It will give you the brief of the interfaces, right? Show IP interface brief. Hit enter. This switch has total 28 ports. You can see over here. Gig 1012 1024 and gig 1 to 1 by 4. These are the interfaces of this switch. So what you will do, you will get the command show interface gi1/0/1 and give the command switch port and hit enter. What it says, the name of the interface, then it says the switch port is enabled, meaning that it is a layer 2 port. If the switch port is enabled, it means that it is a layer 2 port. And then it is saying that VLAN is one, which is default VLAN, meaning that this port is gig 101, which is a default member of default VLAN 1. And there are lots of other things which we are going to discuss one by one in the coming time. But for now, just to check that whether the port of the switch is a layer 2 port or a layer 3 port, the command is show interface gig 101 switch port. And it says that switch port is enabled, meaning that it is a layer 2 port. Now, do one thing, go to configuration mode, go to interface gi1/0/1 and hit enter. Try to give the IP address. Try to give the IP address. It is not taking, right? See, the IP address is not, it's not taking over here. Correct? You cannot see any IP address. You cannot configure IP address. Why? Because it is a layer 2 port and only the layer 2 address will work over here. Layer 3 address is not going to work. So if you want to configure the IP address over here, then what you need to do? You need to make it as layer 3 port. And to make it as a layer 3 port, the command is no switch port. Come to interface of gig 0 1 by 0 by 1 and give the command no switch port and hit enter. Now try to give the IP address. See, the command is working. But before that, just come out over here and just check show interface gig 1/0/1 switch port. Hit enter. See, it says that the name of the port is gig 101 and the switch port is disabled. Everyone is able to see this? Everyone is able to see this? Please put in the chat box if everyone is there with me. So this is how you will configure the port to work as layer 2 or to work as layer 3. Switch port. Now again, if you want to change it, you can change it. If you want configure T interface GI1/0/1 and say switch port, it will again change to layer 2. Now again verify show interface show interface GI1/0/1 switch port and it will say all the details. Correct? But over here you cannot configure the IP address. If you want to configure the IP address, it should be layer 3. So not an issue. Just go to configuration mode again, give the command gi1/0/1 and say no switch port. Now you can give the IP address to this port. You can give the IP address to this port. So give the IP address. IP address 192.168.1.10 subnet mask 255.255.255.0. Hit enter. It has taken the IP address also. Correct? It has taken the IP address. Everyone has configured the IP address. Okay, that's good. Now do one thing, exit and come to interface gi1/0/2 and hit enter. Make this port also as layer 3 port. The command is no switch port. Hit enter and give the command IP address 192.168.1.20 space subnet mask 255.255.255.0 and hit enter. What is the error you are getting? It says that 192.168.1.0 network overlaps with gig Ethernet port 1/0/1. So guys, always remember that you can't give same network range IP on two different ports. Now, if you want to configure the IP address over here also, it should be from the different network, whether it is router or it is switch. You cannot configure the same network IP on two different interfaces. If there are two different interfaces, the network should be different. Two different networks should be configured on each interfaces. Is it clear? Now, the question comes. The question comes when you're configuring the IP address on the switch interface. Is it really getting configured on the interface? Let's verify. We will check the interface, show interface gi1/0/1, right? This gives the detail about the interface. Everyone has given this command. It gives you the detail about the interface. And if you want to check the brief details, show IP interface brief is the command. Hit enter. You can see that the IP address which you have configured, it is shown. It says that interface GI101 has the IP address 1.10. But over here, when you see, can anyone tell me, anyone can find the IP address of this port over, IP address over here? No. But actually in router, when you configure, you can see the IP address that I will show you later. But for now, just say that, see that this is showing that gig interface 101 has the IP address 192.168.1.10. Remember, although this IP address you have configured, it is shown also, but in reality, this IP address is not configured on interface. This IP address is not configured on your interface. Just try to recall, come to my board over here, and I have written something for you about the VLAN ranges, if you remember. VLAN ranges, VLAN 10062, VLAN 4094. This is extended range of VLAN. Actually, this IP address which you have configured over here is not getting configured on gig 101, but in reality, it is getting configured on your extended range of VLAN. And just to verify that, give the command show VLAN, hit enter, and the problem with this simulator is it doesn't support much more about the extended VLAN and you cannot see also. So in the next lecture, what I will do is I will be making the labs on EveNG. Or already I have, but if I will try to boot now, it will take next 5 minutes or more to boot. So unfortunately, due to the limitation, we have to stop over here. But for in the next lecture, what we are going to start is we will be continuing from here, and I will show you something like let me tell you, and the same thing I will justify practically also. So this IP address which you have configured, it is actually getting configured on the extended VLAN. So in my EVNG simulator, which we will be using for advanced lab, I will show you that actually this IP address is configured on extended VLAN, which is nothing but VLAN 1006, and we'll practically justify that in that lab, that the IP address is actually getting configured on VLAN 1006, which is extended VLAN, and that's the purpose of the extended VLAN, which we are going to discuss more in detail. So, any questions, any doubt over here? Any questions, any doubt here what we have discussed? No questions, no doubt, that's good. Allah has a question that if I'm doing subnetting, then also it says that it is overlapping. Let me justify that also practically over here itself so that no doubt remains. What she's asking, she's not asking about the current concept. Huh? She's not asking about switchport and all. What she's saying that I have shown you that you cannot configure same network on two different VLAN. She is saying that she tried to configure two different subnet. Then also it is saying overlap. It should not happen. Let's verify that. What we will do, just for our this clarity, we will be using two different subnet. We will do a subnetting and we will do one second. Let me show you. I have this network with me. Let's say I have a network 192.168.1.0/24. I will do a subnetting and I will say that I will use 192.168.1.0/29, and I will be using another network 192.168.1.8/29. These two network I will be using. Okay. I have a block of 192.168.1.0/24. Now I will be using 192.168. I have done subnetting. I have taken 8 IPs for one network, 8 IPs for another subnet, another network. So this is one network of 8 IPs with the network ID 192.168.1.0, and this is another one 192.168.1.8. So if I am saying this, so the first usable IP will be 192.168.1.1 to last usable IP 192.168.1.6, and the network ID and the broadcast ID of this network will be 192.168.1.7 will be the broadcast ID, which is not usable, right? Similarly over here, first usable IP will be 192.168.1.9 and it will go up to 14 and the broadcast IP will be 192.168.1.15 for this subnet. Again, it is not usable. What I will do, I will be configuring 192.168.1.1 and 192.168.1.9. Everyone knows what will be the subnet. Subnet will be 255.255.255.248. Here also the subnet will be 255.255.255.248. Let's configure and see. I will take interface GI1/0/2. I will say no switch port. I will configure IP address. But yes, Allah, one more thing. Why this might not be happening for you is because you have configured show IP interface brief, and if you will see that 101, it's already configured in the same network. That is a reason, because this is complete /24 network. So if you will use the same network again, it will not work. This is one thing. But we'll do one thing. Either we will remove that, or we will say that this is 2.0 network. Let's change our network because 1.0 is already completely used. 2.1, 2.6, 2.7, 2.8, 2.9. This network we are using now. Why it was overlapping for Allah? Because we have used a complete block from 1.10. Now if you will do the subnetting and you will use the again the same network from this network, it will not work. Of course, it will say overlapping. So I will say configure terminal. I will go to interface GI1/0/2. I will say it is not a switch port, no switch port, and I will configure the IP address 192.168.2.1. Subnet was 255.255.255.248. Enter. I will exit from here. I will go to another interface 1 slash 0 slash 3. I will again make it layer 3. No switch port. It is now layer 3. I can configure IP address 192.168.2.9. Subnet mask 255.255.255.248. Hit enter. It has taken. It should take and it will take definitely. You understood why it was not taking, it was giving, because this is already the complete 255.255.255.0, the complete block you have already configured. Now again you will do subnetting on the same block and you will configure, it will never work. It will again give you overlap. That's the reason. Now we have taken the new network and we have done the subnetting and it is working for you. Anyone else has any questions? So we were supposed to complete at least this SVI part. Unfortunately, due to limitation, we are not doing that and we are running out of time also for today. That's all for today. We'll keep it over here till what we have discussed. And in the next lecture, we are going to discuss advanced topic about SVI, and hopefully we will be performing the complete interval routing advanced labs as well in the next lecture. If there is no questions, it's right time to take break. See you in the next week. Bye bye. Thank you.